In Part 6 of Lecture 5, we will discuss implementing the top-down parser. The parse table is implemented as a two-dimensional array. Each row represents a different non-terminal, and each column a different token. The zeros represent cases where the non-terminal cannot be derived with that particular terminal at the beginning of its right sentential form. Where there is a positive number, it is the number of the production for that non-terminal and that look-ahead token. The numbers are used as an index into another array, where you will find all the symbols in the non-terminal's right sentential form. The algorithm for top-down parsing is actually fairly straightforward. We place the start symbol in a node and push it onto the stack. We fetch the first token and then the loop begins. We pop a node from the stack. If this node contains a terminal, we match it to the current token. If there is a match, we fetch the next token in the token stream. If the node contains a non-terminal, we look up the non-terminal and the token in the production table. If it is non-zero or non-blank, we push the symbols in its right sentential form onto the stack in reverse order. And we keep doing this until the stack is empty. We don't necessarily have to write a table-driven parser. Recursive descent parsers use a series of recursive procedures to parse each of the non-terminals in the language's grammar. Each procedure is a large if-then-else structure. Every time we expect a non-terminal, we call that non-terminal's procedure. Every time we expect a terminal, we check to see if this is the token that we received from the scanner. If the two match, we get another token and move on. If not, we handle the error. The recursive descent parser for the JSON language treats the parser as a class derived from the scanner, which implicitly calls both constructors. Outside of the constructors, only the procedure for the program, the start symbol, is public. The rest are all private, only being called by procedures for other non-terminals. The main program has a declaration for the parser, passing it whatever command line parameters there may be. It calls the procedure to parse the program and then to print the symbol table. This facilitates debugging at this point. The constructor sets the level to 0. We need this so we can see the structure of the parse tree, and then we get that first token. In the JSON language, the program consists of a header, a declaration section, a block of executable code, and a period. First, we increment the level. We need this if we want to make sense of the parse tree structure as it gets printed out. Then we call the procedure for parsing the header, declaration section, and block. Since the period is a terminal, we print the error message and terminate if we find a different token here. The header has three symbols in its right sentential form: the reserved word program, an identifier which is the program's name, and a semicolon. In each of these three cases, we test to see if our current look-ahead token is the terminal that we are expecting. If it is, we print the level of this token, one more than that of the header, and the name of the token. If it is not the one we expect, then we handle the error. At the end of proc header, we decrement the level and return. The declaration section consists of various variable declarations and procedure declarations. These are handled by two recursive procedure calls.